ورحمة الله وبركاته. ازيكم يا شباب؟ How are you today? إن شاء الله we will start in the first lesson of exothermic and endothermic reaction. This part you can find it in your book for official secondary schools, page 115, page 116 and page 117. For IGCSE students, you can find this part in How Fast, page 176 and page 177. For S-level students, you can find this part in Energy Change in Chemical Reactions, page 98 and page 99. By the end of this chapter, you can differentiate between exothermic and endothermic reaction. You can know the definition of both of them. You can know the energy change and the energy diagram for exothermic and endothermic reaction, and also temperature change during the chemical reaction. And of course, you need to memorize the examples of exothermic reaction and endothermic reaction and understand these reactions. By the end of our today lesson, we will know how to calculate the total energy of the chemical reaction and how we can calculate if the chemical reaction is exothermic as total or endothermic reaction. Let's start. At first, we can say that the exothermic reaction is our rich, generous man. Our exothermic reaction is man who has a lot of money and he always wants to help other people. So, the exothermic reaction is rich man. In endothermic reaction, we can say he is the poor man. Poor man usually take money from the rich persons and its energy, its balance in bank will start to increase by collecting money. So it is the example for exo and endothermic reaction. The first one is exo and second one is endo. So it is a relation between persons in life and also it is a relation between chemical reactions. At first we will start to understand that inside your compound we don't have heat. In the system we don't have heat, but we have kinetic energy and we have potential energy and nuclear energy which are stored inside the compound. We explained this part in the last lesson. If you cannot memorize it, turn back to the last video to understand the different types of energy inside the compound. This I start to explain the transfer of energy, kinetic energy, potential energy or nuclear energy from your system, from your reaction in the form of heat. So the internal energy of the system will convert it into heat energy and transferred to the surroundings, or transferred according to our picture from system 1 to system 2. So it is the picture for transferring energy. System 2 will start to gain heat from system 1. System 2 will gain heat and store heat in the form of kinetic energy or potential energy or gravitational energy inside the compound. So the energy from system 1 will transfer to system 2, will transfer in the form of heat. The energy stored in system 1 in the form of potential energy and kinetic energy, and the energy gained by system 2 will also stored in the form of kinetic energy and potential energy. So if you want to understand chemistry, you need to know this part. Now we will start in the explanation what is the meaning of exothermic reaction and endothermic reaction. At first, in exo exits. Exothermic reaction exits energy. So In our reaction, the system will give energy to the surroundings. So the system energy will decrease and the surrounding energy will increase. As the energy will transfer from our system to the surroundings, energy will transfer in the form of heat, and the temperature of the surroundings, of course, will increase. We can see the increase in temperature of the surroundings in our figure, the diagram indicating the relation between temperature and process of reaction. During the process of reaction, the temperature of surroundings will increase directly till reaching the maximum temperature. Then the temperature will decrease directly to have our initial temperature. A total energy change in exothermic reaction, delta H, or enthalpy change, the change in heat content, is usually negatively charged. Heat transfer from the system to the surroundings. We can say that we have very important energy diagram indicating the relation between energy of your reactants and energy of your products. The energy of reactant usually in exothermic reaction is higher than the energy of products. When reactants transferred into products, the system will lose energy. So the change in energy will be negatively charged. We pay money. If you pay money, your balance in bank will of course decrease. So your recharge will change it into negative charge. In the case of endothermic reaction, it is exactly the opposite case. In endothermic reaction, it is the reaction inter-energy. Endo means inter-energy. The enthalpy change in endothermic reaction is positively charged. We can see this reaction exactly in melting ice. In the case of melting ice, the energy will transfer from the surroundings to your system. So, system energy will increase. The system will gain energy. The system will gain money. So, his balance bank will increase. And the surroundings energy, of course, will decrease. As the surroundings energy will decrease, we can see the diagram showing the relation between temperature and the graph of processing the energy. In endothermic reaction, the temperature will decrease directly as the system is storing energy, and then it will start to increase again. The energy diagram indicates that the enthalpy change of your reaction is positively charged, or the change in heat content is positively charged. Energy of your reactants is down. Your reactants' energy is lower than the product's energy. So the reactants will start to gain energy, it will start to take money, it will start to collect money from the surroundings and will transfer into products. By gaining energy, the reactants will convert it into products and total energy of the system will increase. If you gain money, your balance bank will increase and you will gain positive charge. Examples of exothermic and endothermic reaction. We can see the examples of exothermic reaction and endothermic reaction. The first one is burning reaction. Take care, any burning reaction is included as exothermic reaction. Combustion reaction of methane CH4 will react with oxygen to form carbon dioxide plus water. We can say the amount of energy produced from the reaction is 726 kJ per mole. In the next video, we will learn how to calculate the energy of the chemical reaction. So, any burning reaction is exothermic reaction. The second type of exothermic reaction is a roasting reaction. It's used to make a bucket warmer in very cold places. In this reaction, iron reacts with water and react with oxygen to form iron oxide, rust. A third type of chemical reaction, neutralization reaction between acids and bases. It is very important type of exothermic reaction. Dissolving acid and bases also in water will generate a large amount of energy, like dissolving sulfuric acid or hydrochloric acid in water. Take care. Dissolving sulfuric acid H2SO4 in water, you must do it carefully in specific steps. We can indicate it later because this reaction may be explosive reaction. Last type of exothermic reaction is respiration reaction. In respiration reaction, it is type of burning reaction. Just we react glucose plus oxygen to form carbon dioxide plus water and energy. So respiration reaction is also one type of exothermic reaction. This type of exothermic reaction are the main parts and main examples of exothermic reaction. Endothermic reaction, we can see the obvious examples of endothermic reaction in the thermal decomposition of salts. Calcium carbonate and magnesium carbonate salts can be decomposed into magnesium oxide and carbon dioxide. Calcium carbonate also decomposed into calcium oxide and carbon dioxide. We start to heat our example by using Bunsen burner, so we will start to give the system energy. Giving energy to the system will make the system endothermic reaction till we have thermal decomposition to the salt. Second type of endothermic reaction is photosynthesis process. Photosynthesis process is exactly reversible reaction to respiration reaction. Respiration reaction is exothermic reaction in which we start to burn glucose molecule in presence of oxygen to form carbon dioxide and water and energy. In case of photosynthesis, we start to react carbon dioxide plus water in presence of sunlight energy to form glucose plus oxygen. So it is one of the main types of endothermic reaction. A third type of endothermic reaction is silver halide salts decomposition. Silver halide salts are used for making photography films. Photography films are covered with silver halide, so we start to put it in the case of sunlight. It will decompose into silver salt and bromine. According to the level of decomposition, the color will change from the white, black, and gray colors. So we used it for making photography films. Last type of endothermic reaction, dissolving some ionic salts in water like ammonium chloride. It is one type of endothermic reaction. Now we will start to transfer to explain what happens inside your chemical reaction. In any chemical reaction, take care to have chemical reaction. We must say that we make breaking points for the reactants. So for reactants, we will start to break bonds, not break the atoms. So we have 1, 2, 3, and 4 bonds. We need to break the 4 bonds for CH bonds in your compounds. So breaking bonds will take energy from you. To break bonds, you must pay. So you will start to add energy for breaking bonds. The same in breaking the double covalent bond between two oxygen atoms in the case of oxygen molecules. We will start to break bonds. We will start to add energy. By adding energy, we will form carbon dioxide plus water. To form a covalent bond between a carbon and an oxygen atom, double covalent bond, we will collect energy. So breaking bonds take in energy. Breaking bonds in endothermic reaction, but forming bonds releasing energy. Forming bonds is exothermic reaction. The same in the two water molecules. We have two bonds between oxygen and hydrogen inside two molecules of water. So forming bonds is generating energy. So we can say that breaking bonds in reactants is endothermic reaction. It takes in energy from the surroundings. The enthalpy change needed for breaking bonds delta H is positive. So breaking bonds is our poor man who need to take money and store money. So it is with enthalpy change with change in heat content positively charged. Forming bonds is exothermic reaction, so it gives out energy to the surroundings. Enthalpy change for forming bonds is negatively charged, delta H is negative. So we can say that forming bonds giving money, forming bonds giving energy. Forming bonds is exothermic reaction, its delta H is negative. At last, we can say that to calculate the reaction energy, the heat content of chemical reaction equal the energy needed for breaking bonds in reactants minus the energy released from forming bonds in the products. So, if we have chemical reaction, in a chemical reaction contain two main parts. The first part is breaking bonds in the reactants, delta H is positive. The second bond is energy released from forming bonds in products, delta H is negative. So, if your reaction is exothermic reaction, be sure that the energy released from your reaction is greater than the energy required for breaking bonds in the reactants. So we can say that the total energy will be absorbed for the chemical reaction. If the total energy is absorbed, so the reaction is endothermic, and the opposite is correct. Start to watch these questions. Inshallah, we will start to solve these questions together in the next video, inshallah. Thanks for your time. I hope that you enjoy the lesson and you can understand it well. Next lesson we will start to talk about calculation of exothermic and endothermic reaction energy. I hope to give us like, share to your friends to understand our lesson. Don't forget to give us subscribe, and I want to give you small advice. If you miss any opportunity, don't fill your eyes with tears. If something is lost from you, if you got bad marks in any exam, forget it and start again from the beginning. As tears will hide another better opportunity in front of you. Usually we have good opportunities. Work hard, do it hard. Allah will be with you every time. Thanks for your time. See you next video inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.